Number 14. Express this rational expression as in partial fractions. Right, well, it's two parts. Oh, it's three parts to it now, because that's a linear term squared. So I'll have to have a over x plus 2 and also b over x plus 2 squared, and finally c over x minus 4. And then multiply it all out to get rid of these fractions by these expressions at the bottom, so that, just to write it the other way around. So a, having that, will only need one more of them, so x plus 2, x minus 4. B's already got both of them, it just needs that x minus 4. C's got the x minus 4, it will need both of those x plus 2's, and that should be the same as x squared plus 6x minus 4. Then, it's just a case of, you can either equate the coefficients. Is that going to be useful at a first glance? No, I think I'll just use some knockout values. So I'll use x equals 4 first, because that'll knock out that term and knock out that term and just leave this term. So if I do that, if x equals 4, I've got 6 squared is 36. C equals, a bit more calculation here because they're all 4's, I'm going to have 16 plus 24 minus the 4, which is 36, which just means C equals 1. Another knockout value. I can put negative 2 in, so x equals negative 2. Knocking out these terms, leave me with negative 6b equals, and then negative 2 into all of them. So that'll be 4 minus 12 minus 4. So that's minus 12. So b is going to be 2. All the knockout values have been used. So let's just go to equating some coefficients. What's the best one we'll use? Use the x squared terms. So what about the x squared terms? Well, that's got ax squared, that's got cx squared, and that's got 1x squared. So a plus c should equal 1. Well, c equals 1. So that means a plus 1 equals 1, which means a equals 0. So there's the three parts. So for the first part, express it in partial fractions. I've got, well, that's gone. I've just got two of them. I've got 2 over x plus 2 squared plus 1 over x minus 4 for the first part. Right, to the second part. Hence or otherwise, find the first 3 non-zero terms. That just means you have to keep going until you get the first 3. Hopefully it'll just be the first 3. But if you make a zero term, it just means you keep going until you get 3. And the Maclaurin expansion of that, well, it's going to be the hence way in this case. So I'll give it a name. We'll call that f of x equals, so I can refer to the various derivatives. Well, f of x as it stands, I know I'm going to be differentiating, so I'll just put them all into index form. There we are. And whilst I'm at it, I'll evaluate that very first one, the zeroth derivative, if you will. So that's going to be 2 times, that's 2 to the negative 2, so that's 2 over 4, so that's going to be a half, and that's going to be negative, so that's minus a quarter, so that first part is going to be a quarter. Differentiate it, first derivative, so it's multiplied by the power, so it's negative 4 times, and luckily in both of them the inner function's just got a derivative of 1, and then take 1 off the power, negative 3, multiply by the power, take 1 off the power, inner derivatives are just 1, work out that first derivative at 0, so that's going to be, I've got a 2, so that's an 8 underneath, so it's negative 4 over 8, which is negative a half, and that's going to be negative 4 underneath squared, so that's negative a 16th, so that's a 16th, but subtract it, so it's minus a 16th. So I've got 16ths altogether there, that's 8 of them and another one, so it's negative 9/16. So these are turning a bit nasty. But there's only one more to find, and hopefully this is it. Again, multiply by the power, so it's 12 times x plus 2, this time negative 4, no inner derivative to worry about, plus 2 times x minus 4 to negative 3. Work out this one at 0, so that's going to be 12 times, so this time I've got a 16 underneath, so I've got a 12 over 16, that's a 3/4, and that one's got, oh no, because that's going to have a 64 underneath, it's a negative 64 as well, but 2 times, so it's a 32nd, so I'll have to change that into 32, so it'll be 8 of them is 24, take away 1 is 23. The arithmetic's a little bit nasty here. And that's it, at least I've got the first three terms. Now it's just a case of what's the Maclaurin expansion. So what's the expansion of f of x? I'll just say f of x, I'm going to write that thing again. Well, you don't need to put this part down, I'll just put it down as a reminder. The pattern looks like this. N is the nth derivative of 0 times x to the n over n factorial, going from n is 0 onwards. We only want the first three terms. So that's going to be, well, for the first one, n equals 0 what? That was a quarter. So it's a quarter of x to the 0 over 0 factorial, plus the next multiple here was negative 9/16 of x to the 1 over 1 factorial, plus 23 upon 32 being the next multiple here, next factor of x squared over 2 factorial. And it's just a case of tidy that lot up. So that first thing just says x to the 0 is 1, so that's just going to be a quarter. 1 factorial is 1, x to the 1 is just x, so minus 9/16 of x. This bit's positive. 2 factorial is just 2, so that means 23 over double it, so that's going to be 23 over 64, x squared. And then there would be some more terms, but it only asks for the first three non-zero ones. So there you are. That'd be question 14. Question 15. Solve this differential equation. Right, this time, it was a separate one earlier on. This is the one where you'd have to use the integrating factor. This is one where you want to get it into the form of dy by dx and a y, doesn't matter about that side, that being the derivative of this, and then you want some function in here whereby you would multiply by something so that that became the derivative of this one. And then you would have the pattern for the product rule, which you could then integrate back up to the product. And the method of doing that is to get it into that form and find out what this function here is. So divide out by x plus 1. So dy by dx, whoops, minus 3 over x plus 1y equals, dividing by x plus 1 knocks that down to 3. And then you can clearly see that's the part you're going to work on. I want this to somehow amend into the derivative of whatever the original function is. And the way you do that is you integrate this part. Sometimes you give it names like p equals p of x equals whatever you like. I'm just going to do the integral of it. So with the integral of that, the integral of negative, take the sign with it, or 3 over x plus 1 to the x, that's a log. So I've got negative 3 log n x plus 1. Put it all inside though. So it's log n x plus 1 to the negative 3. Because the integrating factor that you use isn't this. The integrating factor that you're going to use is e to the power of that. It's going to be e to the ln x plus 1 to the negative 3. And of course, e to the ln, inverses cancel themselves out, just leaves you x plus 1 to the negative 3. Which just means 1 over x plus 1 cubed. So that's your integrating factor. Isolate that part, integrate it, and then it's e to the power of that you're going to use. So multiply everything by that. But you could state that formally, or you could just at this point say that would then go back to that times y. And I'll put it in just now. So what I've got then is, I've got 1 over, multiplying everything by x plus 1, 1 over 1, x plus 1 cubed, that dy by dx, minus 3 over that to the power 4y equals, and that cancels out just to 1. The important thing here is this, that's the expansion from the product rule. So if I integrate that, it'll go back to the product. So integrating both sides, oops, I should put the wee dx there as well. Integrating both sides puts that back to 1 over x plus 1 cubed y, and that side goes up to x plus some constant c. Then it gives you a pair of values. Get rid of that c as soon as it rears its head. So that says that if x is 1, that's going to be 1 over 2 cubed. So that's 1/8 times 16 equals 1 plus c. Well, that's 2. So c is going to be 2, take away 1, which is 1. So that means c equals 1. Sure, they've done that work at the side. It's sort of messed up the flow here. We'll just put that in a wee bracket then. Which means that I've got then 1, that's really messy now, over x cubed, y equals x plus 1. So y is going to be x cubed, x plus 1 cubed, times that. But notice that's x plus 1, so that's actually going to be x plus 1 to the power 4, and that's it, done. 15b. Find the area enclosed by the graphs of the first one, which is x plus 1 to the 4, and this other one, 1 minus x to the 4. Now they're both just transformations of y equals x to the 4. The graph of y equals x to the 4 is just like a very skinny y equals x squared. This one is simply that's been shifted forward one. Let's just put it down here. So this is the graph I need to transform. That's the graph there. So this is just x minus 1 means to plot a value x, you have to go to the next one, x plus 1, to find the answer and then bring it back. So it shifts back 1. So it's going to shift back 1. So it's going to end up looking like this. So I'll just put that one in there. I don't think I drew that very well. And that's going to cut it. That's going to be at 1, and that'll also be at 1. I'll just put this bit dotted now, this original one. But what about this one? That says negative x and then a plus 1. Now they take place in the inverse order to that. It's like solving that equation equal to 0. To do that, it'd be like I'd have to shift it back 1 first. That takes care of the plus 1, so it's the same as that essentially. It goes back 1, and then the negative tells me to flip it over. So it's going to flip over and end up on the opposite side. They take place in the reverse order to whatever they say there. It's like solving that equation equal to 0. It's minus 1 first, then it's make it negative. So the area enclosed by them and the x-axis, that's this wee area in here. Let me shape. They're going from negative 1 to 1. Well, the whole thing's symmetrical, so I just need to go from 0 to 1. So the area I want then will just be 2 times the integral from 0 to 1 of, just use the one on the right hand side here, so that would be the 1 minus x to the power 4 dx. And that's easy enough because it's a function of a linear function. So it'll just be 2 times, and then that'll be 1 minus x up to 5 divided by 5. I should have put that outside, but also the inner derivative is negative 1, so divide by negative 1. Just take care of that by putting it outside. I should have taken the 5 out while I was at it, 0 to 1. So I've got negative 2/5 of 1 minus the 1 to the power 5 minus 1 minus the 0 to the power 5. So I've got negative 2/5 of 0, take away, and that's just going to be 1. That makes it positive, so that gives me 2/5. So I've got 2/5 of a square unit for the area in here. Number 16. Oh, usually that appears at number 1 or 2 or so. Use Gaussian elimination to solve that system of equations. Well, that just means making up that augmented matrix of coefficients. So I've got 1, 1, negative 1, 6, 2, negative 3, 2, 2, negative 5, 2, negative 4. It's going to be a bit squinty there. Get back in line. And then 1. And then just using elementary row operations, combinations of rows, to reduce this to upper triangular form. So the plan would be that row is ideal. If it wasn't, you could have interchanged rows to get a nice one with a 1 at the top, if possible, not necessary. But then the next plan is make them both into zeros. So to make that a 0, I'll need to take row 2 and subtract 2 lots of row 1. Then that will give me a 0 there. And then I'll have negative 3 take away, that's negative 5. I'll have 2 take away 2. Oh, that goes down to, no, it's 2 take away negative 2, so it goes up to 4. And then 2 take away 12, that's negative 10. To make that a 0, I'll need to have my row 3 and add on 5 lots of row 1 to make that a 0. So I've got 2 plus 5 is 7. I've got negative 4 minus 5 is negative 9. I've got 1 plus 30 is 31. Then the next part would be, just get this to be a 0. The other two are fine, so they can get battered down. So the plan here would be, what's your zeros? The plan here would make that a 0. Well, that means I have to use this row with it, so that's a bit messy. So that's actually going to have to be 5 of them and 7 of them. 5 of row 3 plus 7 of row 2. At least I've only got to do it for a couple of numbers. And I know that's going to be 0 anyway, so it's only here I've got to do some calculations. So I've got minus 45 plus 28 minus 17. I've got 155 minus 70, 85. And then you just start. Now you've got it down to one single thing, the z's. I know that negative 17z is 85, so z will be 85 divided by that, and if it's an exact value 5, yes, it will be 5. Z equals negative 5. Now you notice z's negative 5, go back up here. Negative 5y plus 4 lots of the negative 5 should come to negative 10. Negative 5y plus 20, minus 20 should be negative 10. Negative 5y should be positive 10. Y should be negative 2. I left myself enough room over here. And the last part would be this. X plus the negative 2 minus the negative 5 should be 6. So that means I've got x minus 2 plus 5, which is plus 3, take it across there, and that leaves me 3. X equals 3. Or putting it into order, which I quite like to do for the solution, that would be 3, negative 2, negative 5. There's the solution to the system of equations. Now, it was 5 marks for 16a. Now, B is only worth 2 marks. There wasn't much work for those 5 marks in the first part. So that seems to imply that there's a quick way to get to this. Well, you'll notice that these 2 lines are the same as the 2 lines here, which would imply that you're going to use this result. And you could, because these 3 planes, that's what it's equivalent to, intersect at a point. So if those first 2 planes intersect in a line, that line must include that point. And if I want the equation of the line L, I need to know 2 things on it. I need to know its direction vector, and I need to know a point on it. Well, I've got a point. That point was, what was it again? 3, negative 2, negative 5. Straight away I can see a conflict, because I know the equation of the line is going to be this. For the vector equation, it will be the position vector to any point r instead of p, that stands for ray, would be a point on it plus some parameter, they're using lambda here, lambda times the direction vector. Now that means that all of the parts of that should have a 3, a negative 2 and a 5 in it, but they don't. So I've got a slight problem there. But presuming that that's the way you want to go, then I would do this. To find u, I'm going to take the cross product of the 2 normal vectors for the 2 planes. So that's going to be 1, 1, negative 1, 1, 1, negative 1, cross 2, negative 3, 2. And that'll give me the direction vector. And then with the point on it, then I'd quite quickly get the equation, vector equation, or take the 3 separate parts for the parametric equations. But it's not going to produce this because of those particular coordinates of the point that I got. Still, I'll go through this. Now, I know I could set out the determinant on the side, but there is a simple pattern. It's only the 2 marks. So that would be, the first one would be 2 take away 3 is negative 1. Middle one in the reverse order will be negative 2 take away 2 is negative 4. And then the final one is going to be negative 3 take away 2 is negative 5. So I could use that. Or I could say that's equivalent to 1, 4, 5. So there's my direction vector. I'll just say u dash there because I changed the signs over. There's the direction vector, there's the point, which means, well, I can't go with this, that I should have x, y, z equals 3, negative 2, negative 5 plus some parameter times 1, 4, 5. But that would give me x equals lambda plus 3, but it doesn't. It should just be x equals lambda, which means that point's no use to me. Well, what you could do is this. I'm sure this wasn't the intention, it's only 2 marks. If I know any point in the line, like 3, negative 2, negative 5, I can find other points in the line by stepping along the direction vector. If I go 1, 4, 5, I'll find another point. Another 1, 4, 5, I'll find another point. And of course I could find ones in between. So I could find this point that goes 0, because that's what you want for that, just to say 0 there. That would just take 3 steps back. If I took 3 steps back, I would end up at a new point. So my new point is going to be this. It's going to be that minus 3 lots of 1, 4, 5. So that's 3 off of the 3, which gives me 0. 12 off of the negative 2, which is negative 14, and 15 off the negative 5, which is negative 20. Now I could form my equation from those. X, Y, Z will be any point in the line plus steps of the position vector. In particular, I would have x equals nothing plus lambda is lambda, y equals 4 lambda minus 14, the 4 lambda minus the 14, and z equals 5 lambda minus the 20. But I can't be sure that that's exactly what the intention was there, because it was only the 2 marks. The other way would just be to completely ignore the first part, but in that case, why use the same 2 equations and just start from part B as if that hadn't existed, and then just solve that system of equations to find the line. So I'll do that next. A much simpler way is just to solve the system of equations. There's only 2 equations and 3 variables, so there's a floater, to pardon the expression. And here it says, since x is lambda, let x be the floater. So that means I need to remove one of the other 2, so I'm left with x and anything else. So I'll call those 1 and 2. Easiest thing is to remove the z's. So if I double number 1, if I do number 1 times 2 and then add on number 2, I would have this then. I would have 2 of them. So I've got 2x and 2x is 4x. I've got 2y minus 3y is minus y. But minus 2z plus 2z disappears. I've got 12 plus 2 is 14. Now, and that's as far as it can be eliminated. Now, so you choose one of them to run free. It says let the x be the free variable. So if you let x equal lambda, that means this expression then, I'll call that number 3, that means in number 3 I've got 4 lambda minus y is 14, which means y equals 4 lambda minus 14, and then putting that, that's putting it in 3, and then going back to number 1, I've got x is lambda, y is 4 lambda minus 14, minus z is 6. Take the z over, take the 6 over, so z would be 5 lambda. Take the 6 over, minus 20, which is much easier, of course. Now that's more like 2 marks worth, rather than that other part, finding the line and then the new point on it. Right, so that was part B. Part C, what's the acute angle between the line and the plane? So I've got this plane here, I'll just represent it roughly like that. There's the plane pi with its normal vector. I've got some line that's cutting through the plane, which I can reappear from the other side, some line L. You want this angle in here. Well, since you know the direction vector of the line, and you know the normal vector to the plane, you could use the scalar product to find the angle between them. But that's not the angle to the plane. The angle between the line and the plane means the angle between the line and its projection onto the plane. But of course those are just complementary angles. So you just find that and then take it away from 90. Or you could even just substitute sine for cos in the final calculation. I'll just find the angle between them first of all. Right, so for the line, I've got this. I've got the vector for the line is 1, 4, 5. I've got the normal to the plane is -5 to -4. So I could find the angle between them, just call that theta, by doing u dot n over the length of u times the length of n. So it's going to be, I'm putting all these bits in, I've got -5, I'll just put them down, I've got -5 plus 8 minus 20 over 1 plus 16 plus 25 and 25 plus 4 plus 16, which is, so that's going to be -17 over root 42 root 2045, which means theta, not the angle I want, that's theta there just now, is going to be the inverse cos of -17 over root 42 times 45, which comes to 113.019, so that's 113 degrees, 0.0 degrees. But it says the acute angle, so the actual angle itself must be, take 90 away from that, because I've obviously found the angle, the big angle between that, I found this angle over here, between the normal and the line, the obtuse one. So the acute angle I actually want is going to be, you still take away 90 from it, so the actual angle itself that required will be 113.0. Take away 90, which is going to be 23.0 degrees. That's it.